Hello, everybody. Hi. Okay, today I know you want to eat quickly. I try to be as quick as possible. Okay, now I will try to. My question is, and my keynote is about: is Python still production ready? And for human-facing software. First, to avoid air break or something like that, please remember we are at PyParis. And I respect the code of conduct, don't worry about that. Because it's a keynote, you won't see in-depth technical details. If you want technical details, speak with me or go to the Sync.io tutorial. It's my first time to give a keynote, not my first time to give a presentation, especially in English, but my first keynote. As all first time, I do my best, but yeah, we'll see. And please be gentle. I'm French Catalan with a strong accent. But voilà, that's life. Okay. Is Python too old to be used in production in 2017? When you check the creation date of 4 random languages, you can see Python come from the second millennium compared to Go and Rust. But I don't think creation date it's a really interesting date because when you check the last release date, Python is the same as other languages. But even COBOL, it's incredible but true, is not too far old. Crazy, but okay. Okay, if you go to the conference, maybe some of you are newbies or newcomer in Python. It's normal. Also, a long time ago, I was also a newcomer in Python. And maybe you want to try how to select the right future-proof technology. Yes, I was also in this case a long time ago. But wait a minute. What is a production environment? At least to me, a production environment, it's the goal, in fact, is to provide services. It could be a fat client, it could be a web application, it could be API, it could be hardware. But at the end, the goal is to provide services. And my right definition of production is if the production goes down, you will receive call from users. If you don't receive calls from users, if it's down, it's not production to me. It's for me, it's the best monitoring tool ever of the world, the users. And very happy to call you. Voilà. What do you need to have a production? You need at least a server, a container, or something where you code that runs. Normally, you should need first-line support, at least by email, because the users are often angry to contact you. You need people to mitigate that. Eventually, you need an on-call. This system, especially if you do emergency stuff like emergency call center or something like that, you need people ready to go on the fire every time. Obviously, you need monitoring. And at the beginning of a project, it could be the same person does all roles. Wait a minute. Why do we need to maintain production? Because, to be honest with you, maintain the production, I think it's the worst job you need to do. Personally, if I could only code and nobody use my code, it should be a really fantastic world, but voilà. We need money. And hopefully, some people not affected by money, and we have no profit organization or NGO do that only to help others. But except to do these 2 points, I think, mainly it's for money. But wait a minute. What's wrong with my presentation? Ordering work priority of. In fact, wrong ordering of priorities. The ordering of priorities are very important. how to detect the important and urgent points of your project. Because at the beginning of a project, you have plenty of points, some funny, other not funny. Often, when it's not funny, it's urgent to do, but you don't want to do. But yeah. Alors, let's start from the beginning. You. First, what are your personal priorities, your motivations? Are there priorities compatible to build the project? It's not so a joke. If you don't, for me, if you want to build a project, you must be first in the mind to create something, to improve the world. And if your priority is the happiness, help humanity, or the nature, or change the world, well, at least generate money also, it's good motivations. However, if your main goal of in the world it's only to make fun of others, or make others suffer, or simply burn cars or chariots, voilà. For example, in south of France, it's like that with those barbecue. It's pretty useful. You go to the supermarket, you put stuff inside, and after you use the caddy for that. Yeah. Don't reproduce that, please. What is your project? First, at least to me, you should try to avoid technical tools. Because it's your comfort zone. The first thing you think about a project is about the technical tools. But to success in project, you should try to forget those technical tools. The best source of inspiration is to observe your future users. It's very important to do that because, in fact, the users are your real boss. Your manager or your boss, it's not your boss. It's your user, the real boss of your project. And after that, when you have the business constraint, you try to list technical constraints you have. Okay, the person need a web GUI, need a phone, need to implement something. And only that, you try to match what you need with your actual toolbox. And don't forget one point, try to avoid to over-engineering your project. Here, in this slide, I try to explain to you, at least to me, what's important point to build a good production. On internet, you will find a lot of tools, a lot of presentations, and information how to build a production. Here, I try to explain something very important, but I didn't see that too much. How to safely upgrade your production. Second, how to create reproducible tests to detect regressions. And finally, how to safely upgrade your users. How to safely upgrade your production. Alors, I work for telephony field, and in the telephony world, it's a pretty old business, in fact, telephony. They love a lot big bang upgrades. What does that mean? You have more 40 servers, and you need in one night to upgrade all servers at the same time. And if one server goes down, you need to roll back all other servers. I do that several times. I never do that anymore. It's very bad for the stress. Very bad. For me, the first constraint, you must be able to upgrade only part of production. You upgrade part of production, you observe, and if it doesn't work, you will receive a call from user, you fix, and you deploy on other part of production. Also, a good practice is try to be able to rebuild your entire stack, because it means if you can rebuild your entire stack quickly, it means you don't be afraid to lose a server. And for that, you should use good tools like from DevOps field, like Ansible, or in general, the virtualization with virtual machines or containers. The second point was how to create reproducible tests to detect regressions. You should try to take statistics on what is really used on your production. You should test first the critical feature for your users. Critical means when you receive a call in 5 minutes. If you receive a call in 5 days after, it's not critical. Be sure that your tests are close as possible to the reality of your users. If your users use this smartphone with this firmware, you must have in your lab this smartphone with this firmware. Because, yes, you could mock stuff, you could have another phone, but when you have a big issue in production, yeah, I think it's better to have most close as possible with production. And finally, priorities. It's impossible to test everything at the first step. So it's why it's important to use statistics to detect what's important. And the last but not least point is how to safely upgrade your users. In fact, okay, to upgrade 100 VMs, it's pretty easy. I launch Ansible playbook, 5 minutes later, it's done. But for users, it's not like that. It's not like that at all. Because they use at least the user interface. They be angry about incompatibility change, and when you change the user experience, and if you release major releases, that breaks the habits, like with some products for Microsoft. Yeah, that's life. In fact, for me, the most important thing is to try to prioritize the points complicated to change after the release. Well, the first point is the GUI, the web interface, the user experience is the most complicated thing to change after. If you don't use the right JavaScript framework, it's not an issue. You can change that easily. But if you change the behavior of the web application, you should receive complaints. Also, if you generate hardware for IoT or for phones, for me, if you ship some hardware and finally you discover, okay, I need a new CPU, I need a new RAM, yes, it's too late. The API signature is also important because your partners will use that to integrate with your product, and you won't ask to change each 2 days. Ah, by the way, I've changed this. No, they do the integration one time, and voila. And finally, the foundation of your product. For example, if you want to change, you start your project with MySQL, after with MongoDB, and after with PostgreSQL. But yeah, you need to think how to migrate data because your user pay you for the service, but they don't care at all. You change things behind the scene. How to mitigate these points for to upgrade humans? But for change in GUI, send newsletter, keep informed your users, it's very important. Update the user documentation. For the hardware specifications, the best way to try to upgrade is a new price list, especially with new hardware cheaper. Yes, it will be interesting your users. The API signature, you must have retrocompatibility, and you could use semantic versioning with API. And about foundation itself, okay, because in the project, often in the dev team, you could have a different point of view, it's normal, but at least to me, you need one architect for decisions, because you need to explore several paths. But at the end, when we go to the production, you can take only one pass. And you must have a person to validate. Because, at least to me, democracy, to build the technical stuff is the worst decision system for that. You need a technical production solution, not a politic solution with a lot of compromise. Especially because some people can leave, new people can arrive, and in fact, yeah, it's not normal to change all production stack only because you have person leave or arrive. How to detect you need to change the foundation? For me, it should be good to try a scientific approach. Analyze your global problem. Try to catch differences between the new trends and what you really need in your application. Work on your architecture. You aren't Google or Facebook. They have a lot of problematics. They work on it, but maybe you don't need to have the same contrast as them. And you don't need to be trendy. You only need to be efficient for your problems of your users. Now about machine upgrades process for the complicated point. But here it's pretty easy, in fact, compared to previous points. For the GUI rendering, by now almost no people build flat clients. A lot of people build now web technology, and it's built inside the web technology. For you push a new HTML or new JS, and that's done. For hardware specifications, the cycle is bigger, but you need to put hardware on end-of-life support, and need to support at the end of life. For API signature, it's easy. You need to have different HTTP endpoints, different URLs to go to your applications. And about foundation, for me, you should be able to change the engine of flying plane. What does it mean, change an engine of flying plane? In fact, it means you should try to think your architecture where each element can be replaced, even Python. To do that, you should have a man in middle with external word to manipulate. For example, for most people here, you made web applications. You could, for HTTP, I recommend you Eyepea. Eyepea, it's a proxy for HTTP request, where you can easily rewrite HTTP requests on the fly, and you can redirect HTTP requests on different daemons, for example. It's the same thing for Camalio, but in SIP world. SIP, it's a telephony protocol. But the idea behind that, it's to avoid the big bangs. You migrate step by endpoint. You have your old technology with your old daemon, and you want, okay, I want to test a new architecture, but you can do the daemon, and in your Asha proxy, you say, okay, for this endpoint and this endpoint, go to the new daemon. For the rest, go to the old daemon. With that, you can easily create a new product from a new technology without to break too much your existing platform with the users. And generally, how to build products? For me, you should try to quickly prototype with Python to validate the business model. The users don't understand at all the technical constraints. The only thing they understand is what they can do with application. It's why the time between you discuss with the user and the time you show something to the user, it's very important. And thanks to Python, this time should be very small compared to other languages. After the validation of the business model, you need to catch bugs in your productions, not from your dream. A lot of engineers think about future bugs, but finally, maybe if you first resolve the bugs you have on production, it should be enough. Time to time, you need to change the architecture or use libraries. And finally, hashtag troll alert, you should write automated test suite. What does it mean on that? In fact, okay, automated test suite is very good practice, it's very important, but it costs a lot. If your product doesn't generate enough money, it means the project will stop, and in fact you write automated test suite for nothing. And during the time you implement automated test suite, you don't implement feature for users. It's why you should have balance between the feature and when you write automated test. When you are sure we need to maintain a product for several years, you must have automated test suite. Which points are really important? You and we will make mistakes. Then don't focus too much on fictive bugs at the beginning. 99% of chance will discover other bigger issues. Avoid over-engineering. Lazier is better than fancy. And be able to change the engine of the flying plane. What else for your architecture? You should try to keep in mind several implementation patterns. You have the asynchronous pattern, the thread pattern, the multi-worker pattern. I don't explain too much now the differences between. It should be for tomorrow. But you should try to understand if you have I/O bound or CPU bound problems. You should try to reuse the maximum lower level. And for me, the best advice to handle load is to be able to split your problematic in island, in autonomous island, because the virtual machines or containers are very cheap now. And about asynchronous itself, for your information, the world becomes more and more async. Alors, async pattern is pretty easy to understand, less easy to implement. It simply means when you wait something from the network, for example, an answer from database, but during this time you should try to do something else instead of to wait. It's something in the world is natively async. Programming languages are more and more async native, like JavaScript, Go, C#, or even now Python. And if you see the new protocols with WebSockets on HTTP 2, you'll see you fit async pattern. You have a one-to-one relationship between async pattern and WebSockets. Why do async in my Python? But to be a time traveler, what does it mean? In fact, when you use the async pattern, you have a better control of the time and things executed with the time. Another way to implement is to use queue mechanisms, but here it's built in directly in Python, easier to deploy. To become almost immortal, what does it mean? Because your code is executed in coroutines. You have a lot of new mechanisms to handle stack trace when your Python is executed. And obviously you understand the goal of this slide. It's only to do some commercial ad about my async tutorial tomorrow afternoon. Please come. Okay. Go again in the keynote. Okay, but keep a balance. Don't try to avoid all bugs if upgrades are easy. If you can easily upgrade things and you can be able to avoid brick situations, you don't need to avoid all bugs. Okay, you have bugs complicated to reproduce. Try to do something else, add new features. Try to don't change too much your existing stack because your users don't see the added value of that. If it works and handles the loads, don't change. The bug fixes are the first-class citizen, and feature are the second-class citizen. And finally, but if you have time, you can take some technical pleasure, but only when you finish your homework about bug fix and features. In your context, is Python production ready or not? By the way, what does it mean, production ready? For me, production ready means almost no maintenance cost, easy to repair, it means easy to upgrade, or even better, if you have some auto repair mechanism, it's better. Try to replicate and share the knowledge in several brains. If more you have people in your company knows the architecture is better, and at least one person must have a global overview of the architecture to be sure we don't break something when you do some big changes. And finally, how to select the right future-proof technology? One question I asked at the beginning. For me, no unique answers. Several answers are possible, obviously. And also, you should see the answer depends a lot about the period. For example, when you speak about GUI, in 90s, the answer is most of the time heavy GUI, and now it's web GUI. The conclusion for me, don't waste too much time on that, because good chances the tool you select right now should be obsolete one day. The first conclusion is you should try to build things, understand the lower layers. You will make mistakes. Everybody makes mistakes. But the good thing with mistakes, you should try to learn from your mistakes, and you repeat in a loop. I have some spoiler alert, especially for newcomers. You will fail. It's normal. It will take a lot of time to learn and test. As Euclid said a long time ago, there is no royal reward to learn. You must practice. It's impossible to, except in matrix, it's impossible to learn quickly. And we have unique brains. What does it mean, unique brains? Okay, I take an example to illustrate that. For the Tour de France, for whom doesn't know Tour de France, it's a bicycle competition. You have more or less 3 categories of person. The A category, it's few will be on the top. The B category, some will arrive in the last positions. But in fact, most of the population cannot achieve that. It's the same thing for the development. Some people are able to do a development task in 2 hours. Others need 2 days for the same task. And don't focus too much on your speed to develop things. Because if you are able to build things, it's an incredible power, because most of the population cannot achieve that. And in fact, for me, you should try to know your technical limits. Because a lot of time we have a tendency to mix the competence with the confidence. And at least to me, it's clearly 2 independent variables. You can have a very confident person, but very incompetent. The 2 things is not related at all. You need to push somebody on production to see if it's really competent or is only bullshit speak. Yeah. Usually, when you have the best way to benchmark a dev team, it's to have an issue on production. Because here, usually, people speak louder. I have no anymore message. It's strange. Okay. And also, use the tool is very different of build a tool. It's not because you use a tool every day, it means you are able to build the tools. It's clearly an exponential difference. And finally, you should try to be humble. A lot of people are smarter than you, and conference is very good to discuss with smarter people. And how to rationalize your real expertise and competence? In fact, it's simply to list what do you already do. What are you already coded? What is the complexity of your code? How many people use the product you made? And how many time do you need to do the fireman? Fireman, it means, okay, you have a big issue in production and you need to stop the fire because you have a lot of angry others on phone. And the best counsel about that, it's to handle your frustrations. Because at the beginning you want to build everything, but to be honest with you, we need a long time. The road is very long to build correctly things. I think for me, to build a correct API server, I think I need more 40 projects to arrive to have something. Okay, I push on production. I never listen anymore. It needs a lot of time to achieve that. Now, as a human, you have learned to crawl, and after to walk, and finally to run in this order. You must find what are the crawl, walk, and run steps you need to learn new technologies. It's possible you'll never reach the end of the learning curve. It's like that. It's my English level. Voilà. But I can sleep quick, good. Okay. You should try to match your expectations with the reality. In the real world, when you build a house, it's pretty easy to see the progression. It's pretty easy to know if the architecture is good or not, because the gravity will crash your house. And you can easily find workers. But when you build your application, it's different. It's very hard to see the progression, and when it's really finished, at least to me, I not yet found a good governor to see if you made a good or bad architecture. You mustn't count the number of bugs. The number of bugs only means you have real user use your applications. If you have no bug reports, it means nobody use your application. And finally, it's complicated to find workers for development. And about workers itself, I see two main profiles. The conservative developers who take the leader tool. It's complicated with them to reboot a project and don't care a lot about IT trends. And you have the early adopter who follow news, Twitter, conferences, take care about new trends, and don't hesitate to trash knowledge to learn new tools. And in companies, in general, you have more this profile than this profile, but in a conference, you have more this profile than this profile. It's why you should be prudent about your discussions. And don't forget, we are developers. We are the king of the new world. Software is everywhere now. Tools are more and more complex. It's very good for our job protection. Less and less people will have the global overview. And in fact, we are the god more powerful than Illuminatis. However, look the system administrator role. In 90s, they are the king in companies. They can decide what software can be used in a company. Now, 20 years later, most companies use cloud solutions. Why? Because you have a better service continuity in general. You have no ego problems anymore with sysadmins to change things. You pay for a service directly, and if you want to change, you pay another service. That's all. With a good DevOps toolbox, pretty easy to replace a lot of manual tasks originally done by system administrators. And finally, only few system administrators are becoming DevOps because it's not the same job, not the same skills, and more developer-oriented. But don't forget, if a system administrator should become more and more obsolete, it should be also for our case. It's why try to be humble. You should try, where you work in company, you should try to help other people in the company to sell your product instead of to show you have power on the product itself. Because in fact, it's your role. You are paid for that. You don't you don't be paid to do some politics stuff. You need to pay. You are paid to build products. And because you could be easily replaced by more conscient people, more skilled people, or simply on-the-shelf solutions. In the telephony field especially, we see a concentration of telephony servers solutions, maybe by the artificial intelligence. And finally, because I apply what I say in my presentation, simply me, because I'm humble. Okay, what is your goal for this conference? It's pretty important to know. You will pass 2 days here together to know what's your priority here. Do you want to be up to date about Python ecosystems? Do you want to discover new tools? Or maybe simply discuss with people who have the same problem as you? Or maybe you should show to others you are a king because you are in conference? But don't forget the point. It's not because you are present, it means you are competent. Why people are here? When you speak with a person, you should try to understand why he's here. Is it simply like me for the show? Or it's really to work? It's very important to know that. And finally, the first question, I have an answer for you. Is Python still production ready for me? Definitely yes. And it's true. Yes, for me, because, okay, now I take a lot of time to explain to you what's, at least to me, it's important to check to be production ready. We will apply the production ready definition on Python itself. The first point, very important to me, is the learning curve is the smallest as possible. What does it mean? It means it should be easier to find developers, also to learn development, especially for people not native in development, like sysadmins. For example, in my company, we have more sysadmins than development team, and in fact, the sysadmin produce more and more Python code. And they can do that because it's easy to implement that in Python. And they don't care about Python 2, Python 3, and a lot of fancy things, but okay, it's easy for them to implement. Also because Python has clearly a big community, simply see this event and a lot of other events. And one very important point to me is a lot of libraries in PyParis are production ready. What does it mean? It means it's documented, tested, maintained with a lot of love. It means you can take this library, you install, the doc is true, you have a few bugs, and that I come from other programming languages, is not always true in other communities. Python community is conservative. You can see with Python 2 to Python 3 migration. When you compare, for example, in Ruby world, the migration to Ruby 1.9 was clearly speeder than Python, but Python developers care a lot about productions. And it's also yes for me because between 1.0 and 3.6, Python has evolved a lot. They integrated several patterns. You can do multi-paradigm patterns in general because you don't have only one pattern that works. And also Python already does a reboot to try to clean things. And when you have a big project like Python, at one moment you need reboot because you made mistake at the beginning of the project. Don't forget Python has created when the web doesn't really exist compared to now. And we have a benevolent dictator for life, Guido, very important because he takes the final decision in the debates. And finally, the efficiency. But what does it mean in efficiency? For me, in fact, you can see efficiency from two parts. It can be CPU's part, or performance in general, often it's associated with that. We can see the performance of human to build things with Python. In 90s, machine matters because the CPU cost was very high compared to the human brain. But now, in third millennium, human matters because CPU is very, very cheap compared to the cost of a developer. In fact, you should try to prioritize the human cost than the CPU cost. However, you must not follow the fleur au fusil approach. What does it mean? You should be prepared to go to the battle and see what happens on production. It's why you need to benchmark your product. You should have a staging instance with real data from the production. You should benchmark to measure maximum capacity of your product. You should try to plan future optimization. It's not you have efficiency issue on your production. You don't have time to do labs. You should steal ideas from others, especially during a conference. And you should try to open your chakras about BAs. Maybe some other solution things you don't think, and yes, change your habits, but should help to fix your problem. The collective unconscious is Python is slow. For me, it's the same patterns as a human prejudice about color, about gender. We self-maintain this climate by self-flagellation. You see a lot of blog posts about, yes, but Python is slow, I do a micro benchmark, and when I add a value in dict, yes, it's more efficient in C or Rust. And about benchmark itself. Okay, for example, this is I take some random benchmarks. This is a benchmark where you can see Go is more efficient than Python. Another benchmark where you can see, in fact, Python is more efficient than Go. What to believe? In fact, nobody. You must trust nobody about benchmark. Why? Because the benchmark is true and false at the same time. True in the context where it was launched. False because it will be different of your production needs. And as everything in life, mistake can be made, but it's clearly benchmarks is not representative on a production a lot of time. And my best advice about that is to try to take your own measure on your production. And in case of you are interested in about Python optimizations, I have some advices for you. You should read first this book. It's very interesting to read. You have Victor Steiner, one of Python core developer, has a great blog about that and try to improve C Python in general. But you need also to improve your measure toolbox to be sure you measure what you need, and be careful about automagic efficient new solutions. Nevertheless, Python has a big toolbox to handle efficiency problems, and you should measure, benchmark, and restart again and again. But by the way, do you have efficiency problems? Because performance is an important governor, but nevertheless secondary. You must have first a lot of users before to have to reach this point. For me, you have a priority between efficiency and development time, and at least at the beginning of project, you should prioritize first the development time. To finish about the time-consuming families, you have two main families, the CPU bound and IO bound. CPU, it's about machine learning, scientist things in general. I don't know too much that because it's not in our problematics. And you have also IO bound issue when you wait web services or databases. But it's a good thing to observe the other communities. um, because they use other testing tools. For example, scientific use Cython, PyPy, Numba, Pandas. For network Pythonists, if you use async.io, you have also interesting tools. And by the way, Python, is it fast or slow? I don't know. On the other hand, Python is now fast enough for us to make money in dev time and CPU, and I'm pretty happy with that. Nevertheless, while we keeping an eye on our future growth to be sure not be blocked. And the conclusion is about hunting prejudice. I like a lot the tweet of Glyph. Glyph is the creator of Twisted. If I wrote a program in Python that literally printed money, at least one Hacker News commenter or Vichy should be in Go. I like a lot that. By the way, is Python still production ready for you? If you are at PyParis, we already know the answer. But this keyword goal was also to give some clues to have a better overview for your work and some remarks about the microcosm of a conference. And to finish my keynote, you will make mistake. Yeah, I prefer to say several times because it's not minded in our brains, in architecture, but also in management. I don't speak about management because I'm incompetent about management tasks. Do as little as possible. Don't forget to reboot when you spend more time in maintaining than adding features. And do not be afraid to change the engine. And don't forget, we all have different priorities and needs. Unique response or solution doesn't exist. Be careful about new tools we will need to maintain during a long time when your project is online. And be tolerant about other solutions while it doesn't block you to work. Voilà. Enjoy your conference. See you soon.